A very good day to all of you. Today we are going to learn on the application of non-homogeneous system. Okay, for example, given this network circuit, find the currents I1 and I2. So first step, we have to obtain the non-homogeneous system. Okay, first of all, we'll consider the left loops. The left loops, okay, where we have this one, the currents that flows through the left loops, okay, is indicated by I1, while the right loop is indicated by I2. And then by using the Kickoff Voltage Law, okay, in the left loops, okay, we have this is a voltage across the inductor VL. Okay, plus the voltage across the R1, the first resistor R1. So V R1 will be equal to the supply voltage, the ET. Okay, VL, okay, will be, we have here is L, which is 1. So D in I1 dt. The I1 dt. Okay, you can see here. Okay, in here, I put it here. I1 prime, or it's actually the I1 dt because L is 1. Okay, plus VR1. Okay. Will be the, okay, the currents flows through the resistor R1. We have actually two current. One is the I1, another one is I2. Okay, if we consider I1 is positive, because I1, okay, flowing, okay, clockwise direction, we consider positive, okay, and I2 will be then one is going down opposite direction, this will be negative. So the voltage across the resistor will be IR. Okay, where the I here, we have the I1 minus I2. Multiplied by R here is 2. Equal to the voltage is 200 here. So equal 200. That's why we get okay, the first equation, I1 prime or dI1 dt plus 2I1 minus I2 equal to 200. Okay, our purpose to derive the non-homogeneous system means we have I prime equal to AI plus a vector G, where the I prime is actually, okay, the dI1 dt. dI1 dt. Okay, the matrix A will be, let's say you have the A I1 plus B I2. Okay, G here, vector G, let's say we have the element G1. So in here from the left loops, okay, in order to get the first equation, dI1 dt, that's why the term 2 times I1 minus I2 will bring to right hand side. Once we have I1 prime will be equal to negative 2I1 plus 2I2 plus 200. So this will mean the A is negative 2, the B is 2. Okay, the first row of vector G will be 200. And we get the first equation dI1 dt. And from the right loops, we would like to obtain the second, okay, first order differential equation in terms of dI2 dt. Okay, is AB, let's say this is CI1 plus di2 plus g2. Okay, or we arrive, let's see here, this one, where this is I prime, is I1 prime, I2 prime. Okay, this will be your matrix A. This is the vector I. This will be the vector G. Okay. To get the second differential equations, okay, first of all, I have to erase first because I have no space to write it. Okay. Okay, on the right loops, we have the voltage across the capacitor, where the capacitance 0.5 farads. And here, the current flows through the right loop is I2. And then, okay, so this one is only I2 flow through the resistor 2. But for R1, we have a I1 and I2 opposite direction. So for the right loops, we have the VC plus VR2. Okay, VC here plus VR2 equal to the VR1. VR1 that we obtained in the left loops just now. So VC will be 1 over C integrates, okay, VC is only I2, so integrate I2 dt. VR2 will be, okay, will be the 8I2 or the R2 I2, then equal to the VR1. Okay, so we plug in the C here is actually 1. C is 0.5, 1.0.5. Okay, integrates I2 dt. Plug in the R2, which is 8, so plus 8 I2 equal to VR1. VR1 is 2 I1 minus I2. 2 times, so I1 minus I2. Okay, this is what we obtain here. Here. This is a VC. This is a VR2. Okay, and equal to, this is a VR1. Okay, to eliminate the integral I2 dt, we ddt both hand sides. So this, okay, 8I2 will become 8 di2 dt or I2 prime. Okay, ddt integrate I2 dt will become only I2. 1 over 0.5, you get 2. So this is 2. Remember, you ddt, you have the ddt both hand side. That's why this one will be 2 di1 dt or I1 prime minus di2 dt or I2 prime. Okay, remember, okay, from left loop, we already obtained the di1 dt. Okay. Then in the right loop, okay, we would like to obtain the di2 dt as a title. Then you collect, okay, the same term first. You have 8 I2 prime. The right hand side, you have minus 2 I2 prime. Collect it to left hand side, you have total is 10 I2 prime. Then 2 I2 bring to right hand side will become minus 2 I2. Then here you have 2 I1 prime. Okay. Okay, remember the second equation, what we want is actually only di2 dt equal to how many I1 plus how many I2, or maybe some some other terms, either constants, or exponential term or trigonometric terms. So the the term I1 prime, we have to eliminate, from substitute the equation 1 here, where the I1 prime is minus 2I1 plus 2I2. That's why 10 I2 prime 2 times here, so total we have minus 4 I1, 2 times I1 prime, so this become 4 I2 plus 400, and then this is minus 2 I2. Collecting the same term, we have minus 4 I1, 4 I2 minus 2 I2, total 2 I2, so plus 400. We want only one di2 dt, hence we divide here all by 10. So you get the I2 prime is negative 0.4 I1 plus 0.2 I2 plus 40, equation 1. Put up the equation 1 and equation 2 into matrix form. Now we have like this. If I erase it, put it into the matrix form, means you will have, in the matrix form, you have I1 prime, this is I2 prime, you have negative 2 I1, this is 2 I2, and this one multiplied by, this is I1, I2. And then plus, this one is 200. So you have here minus 2 I1 plus 2 I2 plus 200. Second equation, di2 dt, I2 prime, is negative 0.4. Yeah. And plus 0.2 I2. So this is 0.2 I2 plus 40. Here, 40. That's why you obtain here. So this is the non-homogeneous system because we have the extra vector g here. In this case, the vector g is a constant vector. You may have a case, the vector g is exponential term or the trigonometric term. If your voltage given, let's say in terms of exponential, then your vector g will be exponential term. If the vector g, if the et given is a trigonometric term, then you obtain a trigonometric term for your vector g. Because the vector g is actually come from the voltage term. Without the voltage, we will get a homogeneous system. To solve the non-homogeneous system, first step, you have to find the solution for the homogeneous system. Or it finds a complementary functions. To find the solution for the homogeneous system, first step, you have to find the eigenvalue of the homogeneous system. To find the eigenvalue for the homogeneous system, you have to let the determinant of A minus lambda I equal to 0. This is determinant symbol. A minus lambda I will affect minus lambda at the main diagonal. And then to solve the determinant A minus lambda I equal to 0, remember you have the product of the main diagonal, which is here, negative 2 minus lambda multiply negative 0.2 minus lambda minus product of the other diagonal, means minus 2 times negative 0.4. So minus with negative become plus 0.8 here. And then expand and simplify the system, the equations. So here you have negative 0.4 add up with 0.8, you get 0.4 here. And then see other colors. Yeah, this one, negative 2 times negative lambda become 2 lambda. Then this one, positive 2 lambda minus 0.2 lambda. So we get total is 1.8 lambda. Okay, and then you may have here, negative lambda times negative lambda become positive lambda squared. And you may use your scientific calculator to obtain the value for your lambda. Okay, for example, you can go to your scientific calculator. Okay, number 5 is the equations. Okay, this is actually the ES plus model. Then you want, this is actually the quadratic equation, which is the third option, ax squared plus bx plus c, number 3. Then just input the coefficient for your quadratic equation. In this case is 1. And here ax squared plus bx plus c. So the b is 1.8. Okay, the c 0.4. Okay, change it to floating point. We have, first root is negative 0.2597. Okay, the other root is negative 1.5403. Okay, normally I arrange the lambda 1, which is the smallest value. So negative 1.54 be my first eigenvalue. This is a bigger, so will be my second eigenvalue, lambda 2. Okay, after we obtain the eigenvalue, we have to find the corresponding eigenvector. So by substituting lambda 1, we can obtain corresponding V1 by solving the A minus lambda 1 I V1 equal to 0. Okay, this is a matrix, no longer the determinant. So the matrix is a round bracket. So A minus lambda 1. Okay, lambda is negative. So the A, this one, we have minus and negative. So become plus 1.5403 here. So again, this is also 0.2 minus negative lambda. So become plus 1.5403. Okay, get here. And then since we have the floating point eigenvalue, it's not easy to see whether these two equations are equivalent or not, because we didn't get the integer number floating point. It's not easy to see whether these two equations are equivalent or not. So we have to use a suitable row operations. Okay, to use a row operation, what we use is actually, we are going to reduce this one, the element A to 1. Row 2, column 1 become 0. Okay, using the row operation, which is actually negative A21 divide A11. Multiply row 1 plus row 2, put into row 2. So in this case, we have negative, A21 divide A11. So negative, negative, positive. So we have negative 0.4 divided by 0.4597, row 1 plus row 2, plug into row 2. Okay, I'm going to show how we apply this row operations in the scientific calculator. Where the row 1, I will change it to the symbol, the variable A. Row 2, I change it to B. Here's my calculator. So go back to the computation mode, Then you key in the formula. You have negative 0.4 alpha A. Okay, you notice in your scientific calculator, you have this ES plus, you have the red color, variable A, B, C, D, E, F, X, Y, M. To use the variable, this 9 variable, you have to press the alpha. Because red color, you have to press alpha. The orange color, you have to press a shift. Okay. And then go down 0.4597. plus alpha B. And then this is actually mean we are going to calculate 2 times. Then I input it into the formula or the function in scientific calculator. Then I calculate. When they ask for A, exactly value in the first column. When we are in the first column, remember A is a row 1. A is actually just now A I represent by the row 1. B is a row 2. So in the first column, the A is actually the value for your row 1, negative 0.4597. B is a value for row 2, negative 0.4. Go on. Oh, no wonder I couldn't get 0 because I key in the wrong formula. And let me edit back the formula. This is actually this value divide this value, get positive. However, outside you have negative, so negative 0.4. This 0.4. Now I get 0. In the formula, negative 0.4 is actually coefficient for A21 divided by A11. Means row 1. If row 1 value, you key in by negative 0.4597. And then you plus negative 0.4. Then we'll get this cell is 0. Mean I calculate again. A is this value. B is negative 0.4. Then we get 0. Mean if you don't understand, let me show you in. Mean you have this formula, negative 0.4 divide 0.4597. Mean this is in column 1. This is in column 1. Your row 1 value is actually what? Negative 0.4597. Plus row 2. Row 2 is negative 0.4. The result put into row 2. So this one, this value cancel. So negative times negative positive. So positive 0.4 minus 0.4. That's why your answer will be 0 here. If you calculate manually, mean when you move to column 2, then this value, you move to column 2, same formula, negative 0.4 divide 0.4597, row 1. Well, in column 2, sorry, your row 1 value now, this will be 2. Row 2 value, this one I erase first. Your row 2 value is actually plus 1.7403. This one if you calculate manually. But what I did is actually, because you calculate 2 times, you have the common formula where you just change the value for row 1 and row 2, but you calculate for twice. So what I just input into a formula in your calculator. I use a calculate button where you can calculate several times by just changing the value for your row 1 and row 2. Okay, mean now in column 2, I use the same formula. I calculate against. Now A is my row 1. Row 1 now is 2. Okay, sorry. My row 1 now is 2. Row 2 here 1.7403. Okay, this is 3.46 times 10 to the power of negative 5. Okay, and if I change, let's say to which is okay, approaching 0. Approaching 0. Okay, or you can calculate manually using this way. Okay, against we have two unknowns. Okay, now after the row operation, we notice that second row reduced to 0x plus 0y equal to 0. Means that two unknown we reduce to only one equations, which is negative 0.4597x plus 2y. Or 2 mean you have negative 0.4597 plus 2y equal 0. Or 2y equal to 0.4597. Sorry, this one I have x. 97x. Okay, or y, mean you divide by 2, you get y equal to 0.22985x. Okay, against I will let the variable at the right hand side equal to s. So mean x equal to s, hence y equal to 0.22985s. So x is 1s, y is 0.22985s. By letting the s here equal to 1, hence you obtain the first eigenvector v1 will be equal to 1, 0.22985. And this is a first solution. I1 is 1, 0.22985 exponent. This is a lambda 1 t. Okay. Next, we find the second eigenvector v2 by solving a minus lambda 2I v2 equal to 0. So against here become, because negative and negative 0.2597, this become plus. Similar reason with here. Then we obtain, okay, this is a minus lambda 2I. v2 is, we put it x and y equal to 0 vector. Again, it's not easy to see whether these two rows are equivalent. Hence, we have to use the row operation. Our purpose is actually to reduce a to 1 here become 0 by using the operation negative a to 1 divide a11. So negative is positive. However, outside I have negative. So it's negative 0.4 divided by 1.7403. Row 1 plus row 2, and I'm going to plug in into the calculator like just now. Okay, so I just add it because here 0.4. I want to go down. This one delete. Okay. 1.7403. Okay, and go down a bit to 6. Okay, first of all I show column 1. So I calculate the A is a row 1. For column 1, row 1 is negative 1.7403. Okay, negative 1.7403. Okay, B is a row 2. negative 0.4. So you get result 0 here. 0. And then repeat for second column. We calculate A here, 2, B 0.4597. You get this one. Approaches 0. Hence, second row reduced to 0x plus 0y equal to 0 against two unknowns, but we reduce to only one equation. Mean we have infinite many solutions in terms of parameter s. Okay, again we can let here. Then from equation 1, you have negative 1.7403. In the first one times the x, then 2 times y plus 2y equal to 0. Okay, or 2y equal to 1.7403x. So y will be, we divide the right hand side by 2, y equal to 0.87015x. Okay, again, we'll let the variable at the right hand side equal to s. So mean we'll let x equal to s, hence y equal to 0.87015s. So x is 1s, y is 0.87015s. Okay, by letting the s equal to 1, you obtain the second eigenvector v2, which is equal to 1, 0.87015. The I2 is actually your v2 times exponent lambda 2t. Hence, the general solution for the homogeneous system, okay, you can put it, this is what we call the complementary functions. What we call this one? Complementary function. Complementary function. Complementary function. There's a in the IC, vector IC or I1, I2, C equal to the A, this is a V1, exponent, this one is the lambda 1 T plus B V2 exponent lambda 2 T. If you have the IC, the complementary function or solution of homogeneous system will be your A V1 exponent lambda 1 T, okay, plus B V2 exponent lambda 2 T. So this is only the homogeneous solution. Okay, remember what we have is actually the non-homogeneous system. We got the vector G here. So to solve this non-homogeneous system, first step, you have to solve the homogeneous system or define the complementary function. After that, we use undetermined of coefficient methods where we choose the particular integral IP based on the form of vector G. Okay, based on the form of vector G, if vector G is a constant, then we'll choose the IP also a constant vector. Okay. Since the G constant, then we choose the, okay, this is the IP. Vector IP is also constant vector. We have used the AB, okay, variable in the complementary function, then we use C and D. Okay, after we have chosen the the IP, we have to check whether this IP clash with the IC. Okay, constant vector. But here, this is a vector, depend on the exponential term. Hence, this is not clash. If not clash, so this will be the correct IP that we use. And then remember, we have the system. What we have the system is actually, remember we have the system is, okay, what we have the system is I prime equal to AI plus G. AI plus G. Okay. So from the IP, you need to find the IP prime. When you DDT the IP, since the constant, the IP prime will be 0 vector. So you plug in the IP prime into I prime, the I plug in by CD. Okay. So this is a AI plus G equal to IP prime. I mean I reverse. This is actually the A, this is the I plus G equal to I prime. Okay. And then okay, after that, okay, using the matrix okay, multiplication we have here with first row. So this is a 2 by 2 matrix times a 2 by 1. So can be multiplied. The result is a 2 by 1 vector. Okay, or before that, okay, we move the constant vector plus 200 to the other side, so become negative 200, negative 40. And then we multiply, okay, using the matrix product. We have here is actually negative 2C. Negative means okay, product of matrix, row times a column. So negative 2 times C, we use other colors. Then we have okay, negative 2 times C plus 2D. Yeah, put it here. Negative 2C plus 2D equal to negative 200. Okay, and second row, okay, it takes a second row times second column, so we have a okay, second row first column, which is negative 2, negative 2 times C plus 0.2 times D. Means we take this row and here. So second row, first column, and we get is negative 0.4 C plus 0.2 D equal to negative 40. And then you may solve these two simultaneous linear equations using your scientific calculator. I'll show you here. We go to the equation modes. This is two simultaneous equations, which is the first options. Key in the coefficient for your two simultaneous equations. So first row is negative 2. Okay, first row, second column, 2. Then the constant, vector B, negative 200. Second row, negative 0.4. Okay, first row, second row, second column, 0.2. And this is negative 40. Okay, the x is actually, because the x tally with our variable c. So hence c we have 100. The y is actually tally with the variable d, where the d is equal to 0. In exam, you are allowed to directly use your scientific calculator to obtain the c and d. You no need to solve it manually. Okay. Thus the IP which consists of I1, I2P is 100 and 0. This is what we call particular integral IP. Step 4, the general solution of the non-homogeneous system will be I equal to your IC complementary function plus the particular integral IP. Okay. Yeah. This part is the IC obtained from homogeneous system plus this is the IP. Okay, with this, thank you for your attention.